On today's episode, 60 years ago, there was a small modular reactor. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Imagine for a moment that you're an engineer with a tough problem. Your problem is to provide electric power to a remote research station in Antarctica. Think of the challenges: extreme cold, ice, complete darkness 4 months a year, and isolation. Antarctica is literally thousands of miles to any logistics support, and ships can visit only briefly during the summer months. Now, you can fly in diesel generators and fuel, and that's still done today, but think of the cost of moving heavy liquid fuels by transport. What if there was another way? Well, the nuclear division of the Martin Company thought so, and they created a small transportable nuclear power plant called PM3A to power the U.S. Antarctic Research Station at McMurdo Base. It was essentially a scaled-down commercial nuclear power plant, a pressurized water design with primary and secondary loops generating steam to drive a turbine linked to a generator. Design output was 1,800 kilowatts electrical, operating at an 80% power factor. Waste heat operated a desalination plant to supply drinking water, 14,000 gallons a day. The entire reactor and turbine assembly was designed to be broken down for air transport by C-130, although it was actually carried to Antarctica by Navy ship. Today, as we're all talking about small modular reactors, none of this may seem particularly unusual, but the interesting thing about this is that it all happened in the summer of 1962. And despite the extreme novelty of the design and the difficult conditions under which it was expected to operate, far from technical support and potentially isolated for weeks or months at a time, the entire system was tested and qualified with only 23 months of testing. It lasted for 10 years. So what happened? Well, leaks, particularly between piping connections and cracks due to chloride stress corrosion, combined with the need to maintain a 25-man crew to operate the system, led to its removal in 1972. Now, over its 10-year service life, the PM3A system had an availability of just over 72%. By 1973, the reactor was cold and decontamination operations had started. For detractors, the system was a failure. But take a close look at the final operation report, which is available online, and it shows that the system failures were the result of not just the deficiency of materials available half a century ago, but due to repeated sensor and control electronics problems, along with plant shutdowns for maintenance, repair of systems not involved in the reactor itself, plus crew training and changeover. So could a system like this be built today with today's digital controls and today's materials? Without doubt. Back then, this then-novel system designed by teams of engineers with slide rules and less computing power than a pocket calculator assembled and delivered their reactor and generator system in less than 2 years. Now, I think that with modern digital twin and simulation technology, it could be done today in 2 months. So in an age when Germany wonders if it will freeze in the dark and environmentalists demand the complete shutdown of fossil fuels by 2050, why aren't we building something like the PM3A right now? Well, that's it for today's episode of End of the Line, brought to you by Engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit Engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.